to help study for the test. Okay, let's talk about where is it? So I wrote up this document. I'll post this along with this video, all the stuff that's going to be on the midterm. So here are all of our topics. A lot of this is from test one, of course, right? And midterm covers everything up to now. So we get the order of a DE. Those are, like, if you just look at it, the highest derivative is the order. Determining if a DE is an ordinary or a partial. Like, if you see the partial symbol with the, that's not one you should get wrong. Sometimes people do, and it confuses me. I just put a mark on there and it won't. Okay, there we go. If you see the word, or if you see the partial derivative symbol, you got yourself a partial derivative. Otherwise, it's an ordinary derivative. Checking if a DE is linear. If you're doing anything to the y's that's non-linear in nature, nobody cares about the x's here when we're talking linearity, just the y's. If you've got a y squared or an e to the y or a y prime squared, you're non-linear. Anything like that. Checking to see if DEs are exact. You just got to practice those. But that will be on the test. Here are all the different methods of solving DEs we've learned. We got separable, linear, exact. We also learned Bernoulli. Those are Bernoulli DEs are just rough. Like, I think I did one video on them. I don't even remember if you had a homework problem on them. I'm not going to put that on a test. They just take too long. Maybe I should make up a group assignment so you at least do one. Not going to be on the test. Either test two or the midterm. Homogeneous and non-homogeneous. Higher order, higher than first order. DEs with constant coefficients. Linear, of course. Wronskian, linear independence, IVPs. And then, was it last class, I think, last Zoom meeting, I went through the mass on the spring problem. Make sure you completely understand that problem. Like, I don't know what better hint to tell you than I'm putting that problem on the midterm with different numbers. And I kind of walk you through it. But if you've studied the problem a little bit, it shouldn't be bad. Okay, and then I did an example. I don't know if I'm going to go through all these like right now, step by step. I'm going to upload this and you can look through them. Heck, check them. Who knows? Maybe I made mistakes. I think they're all right, though. So separation of variables, getting all your y's on one side, all your x's on the other, and then integrating. Remember, you are never allowed to write this symbol, the integral symbol, without having a differential there. First order linear, we solve these using an integrating factor. I want to see all the work here. Even on test two. Like, here's another place people get caught using Chegg is too many steps get skipped. The Chegg tutors like to skip a lot of steps here. So that rouses suspicion right there. You start skipping steps on first order linear, I'm immediately suspicious. And once I get suspicious, I start really analyzing everything you've written. And then I can tell. And then I set up a meeting and it's everybody. Every single person. It's like, oh no, I didn't cheat. I learned that method watching a YouTube video. Because they use some method that's not taught in class, some alternate method, and they're always like, oh yeah, I don't know, I watch videos for fun. Like, literally, I've heard the same story 15 times now. Oh, I watch YouTube videos for fun, and I must have picked that up from some video. Okay, well let's open your computer right now, share your screen, and let's find that video. Check your history. Oh, I delete my history. Oh, so you can't find that video. Okay, teach me the method. What's it called? Oh, I can't remember. And this goes on for like 15, 20 minutes, and then eventually every single time. Okay, yeah, I have a Chegg account. I submitted it to Chegg. You get caught every time. You're going to deny it at first. You're not going to be able to find this mysterious YouTube video you claimed you learned it from because it doesn't exist. And the very first thing that rouses my suspicion on every one of these is people skipping steps on these problems. So, like, if you don't know how to do a problem, just skip it. Don't cheat on it. So we find the integrating factor, multiply everything by it. If we've done everything right, the left-hand side will be the product rule derivative, the full derivative of y times the integrating factor. So then we integrate both sides. Don't forget to put your dx on both sides. That's a place where a lot of people lost a point on test 1. If you're writing an integral, you better have a derivative. That's not a differential. That's 1 over. You can look at it like that. That's kind of like a 1 over dx. You gotta have the dx. Then the antiderivative of the derivative is just the thing inside. And then we solve for y. Exact DEs, again, a place where a lot of people look suspicious here, is just clearly not knowing how to do these. Make sure you know how to do exact DEs. And then all the stuff we're doing right now, the second order linear with constant coefficients, homogeneous. I did all 3 versions here where we get real roots, we get repeated roots. When you get a repeated root, you have to throw on an extra x or an extra t or whatever. Complex roots, you get roots like a plus or minus bi. Then your general solution is c1 e to the a cosine bt, c2 e to the a sine bt. So the a goes in the exponentials, the b goes in the sine and cosine. We don't use the plus or minus. We don't worry about that. We just use, here's a, here's b. Then we got our non-homogeneous ones where, like we were just talking about this, you solve the homogeneous version first, then assume a particular form for your particular solution, and it should match whatever kind of form you got here. If you got sines and cosines, then you need both sines and cosines for your particular solution. If you got exponentials, you need exponentials. If you've got a polynomial, you need a polynomial. Again, a lot of mistakes happen here. If you're solving an IVP, an initial value problem, so if this said here, 2 initial value conditions, don't plug those in here and get C1 and C2. You'll get the wrong answer. You have to wait until the end. You have to wait until you get the whole thing. Then you plug in your values. And then Wronskian, linear dependence. So I picked like a pretty easy problem here. These guys are obviously linearly dependent. I mean, this third one here is just 4 times that one minus twice this one. If one of them can be gotten by adding versions of the other ones together, you're linearly dependent. So here we'll see that when we calculate the Wronskian. So we write the functions here, their first derivatives, then their second derivatives, and we take this determinant. So you got to remember how to do the determinant of a 3x3. And this is like every one of these pieces is 0. We just get 0. So these are linearly dependent. So now I want to find coefficients that I can multiply these guys by so that when I add them all up, I get 0. So it's just kind of there are an infinite number of answers here. It's just kind of glance at them and say, okay, well, how can I make the x's cancel out? Well, I would need -8 and 8. So if I multiply that guy by -4 plus him, that'll cancel the x's. And then if I multiply this guy by 2, I'll get a +6 and a -6. That'll cancel the constants. So these coefficients times those guys, that'll all add up to 0. Okay, and then those other ones working backwards, where they give us the solutions and they want us to work backwards and find the DE. So we know our roots here are going to be 5 and -6. So the factors will be lambda -5 and lambda +6 minus a negative. If we FOIL that out, we get this, and then that's it. There's our DE. The power will correspond with the order of the derivative, and we just bring the coefficients along. That should be a 30 right there. Because 30. Hey, that's everything that's going to be on the midterm. Like the last half of what we just talked about is what's going to be on test 2. So studying for one helps you study for the other. Okay, I think that's all we need to talk about. I think that's a good place to stop.